So in this lesson we're going to understand energy conversions, power formulas and kilowatt hours. You've done energy conversions previously. You're just changing from one type of energy to another type of energy. What we're going to focus on is converting electrical to something else. Electrical is the energy that comes from the wires, and that transfers into something like heat or sound or light. So for something that will convert electrical to heat, you can say, of course, a heater, a toaster, a light bulb, hair straighteners, anything like that. Something that converts it to light, you will obviously say the light bulb itself, it creates light. Things like that. Light bulb makes more heat than light, funnily enough. So this happens when particles are moving very, very fast, bump into each other, creates friction, and things get hot. So electrical power, if you remember the meaning, energy is the ability to do work. Power is how fast energy is transferred. That works in circuits as well. So if an appliance, which is something that uses electricity, is more powerful than another, it means it will use the energy faster. So if something's more powerful, it uses energy faster. So now we know powerful things is how fast energy is used. So we can put that into a little formula, energy being used in a certain amount of time. P equals E over T, PET. That's the first formula for power. An example, a radio that uses 27 kilojoules of energy in 5 minutes. We have kilojoules and we have minutes. Change it, please. Kilo means 1,000, so 27,000, 5 minutes, which is 300 seconds, because there's 60 seconds in a minute, so 60 times 5, 300. And that means 27,000 over 300, 90 watts. Easy. There's another way to find power using current and voltage. We did a little lab experiment on this, and we found that P is directly related to current and voltage. So P equals IV, PIV. This is the second formula to find electrical power. And if we don't know I, or we don't know V, we can substitute Ohm's law into this. So we can say P equals I. Instead of V, we can say IR again, because we also know V is IR. So I will not write V, I will substitute IR in there. So I times I is I squared, P equals I squared R. We also know P equals IV, and if I rearrange this formula, I is V over R. Taking this, taking the R to the side, it becomes divide. So V over R, I'll substitute that instead of I. So I'll write V over R times V. We know that V times V is V squared divided by R. So that is the fourth power formula. So we have 4 in total. P equals E over T, PET, PIV, I squared R, and V squared over R. This one we will only use if you have something to do with time or energy. But these 3 can be chosen depending on the question that you get. For example, the power rating of a microwave that has a current of this and is plugged into the voltage of this. We have I and we have V. Out of the 4 formulas that we know, we can use P equals IV. Direct substitution into this one. 3.3 times 240 equals 792. Another example, power. You want to find P again, no need to rearrange, just finding P. You have a resistance and you have a current. You have an R and an I and R. Which of the formulas we can use? We can use I squared R. So I'm choosing that formula, I squared R. And I know my I, 1.2 squared. I know my R, 5. And that will give me 7.2 watts. So that's 2 practice questions on how to use power. We will do more in class. FYI, if you ever get asked what is a superconductor, it is basically a conductor. It allows electrons to pass, but it has almost 0 resistance, which is amazing under certain conditions. It can be quite dangerous as well, so be careful not to touch it with your bare hands. You also need to know what a kilowatt hour is. A kilowatt hour is a unit of energy. You might think it says watt, it's a unit of power. No, it's actually a unit of energy. Kilowatt hour, this is power and this is time. So obviously we know that P times T is energy. Anyway, so P is E over T. 1 kilowatt is 1,000 joules per second, because kilo means 1,000. power being energy over time, joules over seconds. That's how we have joules per second. Okay. We also know there are 3,600 seconds in 1 hour. 1 second times by 60 to make a minute, times by 60 again to make an hour. 1 times 60 times 60, 3,600. So then what I can say is 1 kilowatt hour is 1 kilowatt 1,000 multiplied by 1 hour, 3,600, because I said power times time. Power times time. We get 3,600,000 joules. That is 1 kilowatt hour. This is very useful to make bills and things easier, because all of these numbers, if you're trying to measure the energy used, you'll have millions and millions of joules of energy. So we just make it simple and use kilowatt hours. 1 kilowatt, 2 kilowatts, 3 kilowatt hours, rather than 3,600,000 and 7 million and so on. Makes it easier. So an example question that you might get is a holiday goose. It's cooked in an electric oven for 4 hours. That's our time. Assuming the stove draws a current of 20 amps and has a voltage of 220 volts, so there's my I, there's my V, and it uses electrical energy that costs this much. This is the costing. We'll deal with that soon. How much does it take to cost up your goose? Figuring out how much it will be costing you. First of all, you can find the power. We need to know the power. P equals IV. 20 times 220, 4,400. But remember, we're using kilowatt hours, so I'll change it to kilowatts. 4,400. I'll divide that by 1,000 to get me into kilowatts. That's 4.4 kilowatts. First part is done. Next, I need to know the actual energy itself, how much energy it's costing. That's when the time comes in. I'll take my power, whatever I found, and I'll multiply it by the time. This is 4 hours. Normally we change it to seconds, but remember, kilowatt hours, right? Kilowatt, 4.4, times 4 hours. I will keep it in hours. It's the only time we're keeping this in hours. Otherwise, it would be seconds. 4.4 times 4, 17.6 kilowatt hours. That is the energy we're using. I now know my cost is this per kilowatt hour. So I will take my kilowatts that I just figured out, 17.6, and I will times that by the cost, 0.085. And that means I will get a final answer of 1.50, which is $1.50. Okay, easy.